Hi, we are going to find out how to get a new graph of a function given an old graph. In particular, suppose you are given a graph of a function y equal f of x, then you can get the graph of closely related equation by translation, reflection, and scaling. What you mean by closely related equation? Let's look at translation first. If you are given the graph of function y equal fx and you do a little transformation, let's say I have y equal fx plus c, so you have changed the equation by adding a plus c at the end, or y equal fx minus c. Now what you are doing now, this is what we call a vertical translation. You shift the graph upwards or downwards. For example, if you are given the graph of y equal to x squared, then what is the graph of y equal to x squared plus 2? In this case, you shift the graph vertically up by 2 units. So you get a new graph. This is the graph of y equal to x squared plus 2 by moving up 2 units. How about if you change the equation, instead of y equal to x squared you have initially, you have y equal to x squared minus 2. Then you shift the graph downwards by 2 units and you have this graph here. This is the graph of y equal to x squared minus 2. This is for vertical translation. Now you can also do horizontal translation. If given y equal fx and now you have y equal f of x plus c, what does it mean? For example, you have y equal x squared. Now you change the x to x plus 2, so c equal 2 now. Then the graph will shift to the left. So this is what we call a horizontal translation. So you, instead of the position of the graph with y equal x squared here, now with y equal x plus 2 squared, you shift to the left 2 units, and then you get this graph. After you shifting 2 units to the left, so you get the graph of y equal x plus 2 squared. Now what happens if you change the equation? Instead of y equal x squared, you change the equation to y equal x minus 2 squared. You shift the curve to the right 2 units, you get this curve for y equal x minus 2 squared. So in conclusion, when you have y equal to f of x plus c or f minus c, you shift horizontally, whether to the left or right, where it's easy to see. You just set x plus c equals 0, you get x equal to minus c. Then you just know, from there you shift the origin to the point minus c. Write down the equation of each graph. So let's say the first one, this is y equal fx. Now if you are familiar with absolute value, this is very likely to be absolute value of x here. Now the second graph is actually shifting the origin to 3. So this is the equation of f of x minus 3. So that is shifted 3 units to the right. So this is the equation of y equal to x minus 3. Now for the third graph is you have shifted the graph horizontally 3 units. Then you shift up 2 units, right? So this is the equation of the graph. First you shift horizontally 3 units to the right. Then you add 2 units by shifting outward. So this become y equal to absolute value of x minus 3 plus 2. So let me give you another illustration. If you have fx equal to sine x. Now what happens if I change the equation, say gx equal to sine x plus pi over 4? Then we know that the sine curve looks like this, a standard sine curve from 0 to 2 pi. This is a standard sine curve. Now how about gx equal to sine of x plus pi over 2? This is a horizontal shift. So you have to shift to the left or right. How do you know it's left or right? You just set x plus pi over 4 equal to 0, and then you get x equal to minus pi over 4. So you know that it's negative, so you shift to the left, negative direction of x. So you get the graph of the sine curve again. It's very similar, but instead of starting from 0, you start from minus pi over 4. So if you can start with minus pi over 4 and shift it like this. So after you shift it, this one will be 2 pi minus pi over 4. So it's 7 pi over 4. Okay, this one will be pi minus pi over 4 will be 3 pi over 4. And this is the graph of y equal to gx in one cycle. And we have known this before. This is what we call a phase shift. So going back to the graph, you can make some comparison that this is my y equal fx, then y equal gx will be shifted at pi over 4. So more or less pi over 4 is here to the left, minus pi over 4, right? Then you just do a shifting and you'll find that you get something like this after you do a shifting. Now another transformation I want to talk about is called reflection symmetry. This is a symmetry by changing x to minus x. For example, when you change x to minus x, this is what we call a vertical reflection. So for example, if you have equation y equal f of x, or y equal to square root of x in this case, then changing the x to minus x, you are doing a vertical reflection in y-axis, and you get the other half. This is called vertical reflection. Now, can we do a reflection in horizontal in the x-axis? Yes. If you have y equal to fx, now you insert a minus sign in front, then this is the same as doing a horizontal reflection. So if you have y equals square root of x like here, after reflection in the x-axis, you get this. Alright, so this is horizontal reflection in x-axis, whereas the one I have on the left is vertical reflection in y-axis. Let's look at the example. Now this is a little bit more complicated here. I have asked you to sketch the graph of y equal to 4 minus x minus 2. So how do we start? First, you start by simple one first. What is y equal to fx equal to? To start with, maybe I start with absolute value of x first. So I got the graph of y equal to absolute value of x. Let's draw out the graph of y equal to absolute value of x. Look like this. Okay, this is y equal absolute value of x. Then you change to the graph of say y equal to g of x equal to absolute value of x minus 2. Now I am doing this because it may be not so easy to get the graph straight away, so I do one step at a time. So y equal absolute value of x to y absolute value of x minus 2. So how do you do this? This is done by a horizontal translation. So what do you translate to? So you set x minus 2 equal to 0, you get x equal to 2. So you move to the right, since this number is positive. So you move to the right and you get the graph this time. Instead of meeting point at 0, now you move to the right 2 units. So a new graph now, move to the right 2 units. This is a new graph. Whereas initial graph you have was here. So you see the difference. This is called horizontal translation. Initially is y equal absolute value of x, and now for the new graph you have y equal to absolute value of x minus 2. But this is not complete yet. After you got the graph of y equal absolute value of x minus 2, let's move on. So let me copy the graph here. And now I move here. So now I want to look at another one. Let's say another new graph. So this time I want to look at y equal to minus x minus 2. Now this is a reflection in x-axis now. So you're going to do a reflection in x-axis. So when you do a reflection in x-axis from the earlier rate curve, now after reflection you got this come out in x-axis, right? So this is the reflection. The rate piece here come to here, and this piece come to here, and this is the graph of y equal to minus x minus 2. And finally I do one more transformation, which I need another color. Let's say I have a really thick color now. Y equal to, the equation I have is 4 minus this. Now this is the same as minus x minus 2 plus 4 minus absolute value of x minus 2 plus 4, and this is a vertical translation. So you translate 4 units up. So it becomes, after I translate 4 units, let's say 1, 2, 3, 4. After I translate 4 units up, this is the original black curve. And after I translate 4 units up, I become something like this. Up, go up 4 units, right? So this is y equal to 4 minus absolute value x minus 2. And this is the graph. Now you can check the graph by using grammatical. So let me go to grammatical to help you see the graph. Here is the graph using grammatical. Let me enter the equation. Y equal to 4 minus absolute value of x minus 2. And then I press enter. Then you can see the graph look like this. I can see a better picture by zooming out. You can see how the graph will look like.